Hello everyone. Welcome to my first video in the AI Foundations for Developers series. AI is everywhere today. Every product claims to be AI powered. Every roadmap mentions agents, copilots, or RAG. But for most developers, the real question is, where do I actually start with AI? As developers, we already understand APIs, databases, and systems. The issue isn't compatibility. It's the most AI content skips the foundations and jumps to tools. These tutorials looks impressive, but without understanding what's happening underneath, they become copy-paste exercises. When things break, you don't know why, and that's risky in production. Think of AI like system design. You don't start with Kubernetes. You start with processes, networking, and scaling basics. This series follows the same bottom-up approach. By the end of this series, you won't just use AI tools, you will understand them. AI will stop feeling like magic. You don't need ML or data science background. If you understand APIs, databases, and basic math intuition, this series is for you. Each topic basically builds natural on previous one. No sudden jumps, no unexplained abstractions. Everything in modern AI starts with vectors. If vectors make sense, the rest of the stack becomes intuitive. So, let's begin where modern AI actually starts. What is a vector and why does AI care so much about it? As I said earlier, we are starting from the very bottom of the AI stack. Before agents, before RAG, before memory, we need to understand vectors. I'll explain this as a developer, not as a math lecturer. If you understand this video, everything else in AI will start making sense. Almost every modern AI system relies on vectors somewhere under the hood. When you hear terms like semantic search, vector databases, memory, or embeddings, they all talk about vectors. So if vectors feel fuzzy, the entire AI stack feels like magic. Our goal today is to remove that magic. A computer doesn't know what a cat is. If it doesn't know what happy, angry, or revenue growth means, but it's incredibly good at math, especially with numbers and distances. So, the big question is, how do we translate meaning into numbers? A vector is not mysterious. It's just a list of numbers. What makes it powerful is what it represents, the meaning. Different inputs produce different vectors, and similar inputs produce similar vectors. Best mental model is geometry. Each vector is a point in very high dimensional space. You can't visualize 768 dimensions, and that's okay. What matters is closer vectors mean more similar meaning. Notice something important here. The model isn't matching keywords. I love dogs and dogs are amazing. Use different words, but same meaning. Vectors capture semantic similarity, not the exact text. Vectors don't come out of thin air. They are generated by embedding models trained off massive datasets. So, important rule here is vectors only make sense inside the same model space. You cannot compare vectors from different embedding models. Once everything is a vector, the problem becomes math. We measure distances between vectors. This is why vector databases exist, to do this fact at scale. And this idea powers search, memory, and retrieval in AI systems. You can't look at vector and read the meaning from it. Vectors are not for humans. They are for machines. They are a bridge between human concepts and machine math. If you remember one thing from this video, let it be this. Vectors are language in AI systems used to represent meaning. In the next video, we will talk about dense versus sparse vectors and why real-world AI systems need both. That's where things get really interesting. Thank you for watching.